In the previous tutorial video, we learned about the architecture for the two important clusters for your ETF starter projects. Let's recap very quickly. So we got two clusters there. So we got users commands and also we got the model cluster. And what we did previously was in order to try to modify the external behavior of your application, we try to introduce changes either to the ETF model class by adding new features or redefine the out feature for outputting the string. That was change number one. Or you can also make changes by calling the corresponding feature over here for each of the command classes. So those were the changes we made. So these are basically the two kinds of changes you can make in order to modify your program behavior. That's what we did from the previous video. So now, in this current video, we're going to show you how you can gradually adapt the default ETF model classes and also the ETF model access class. So these two classes are just there as a placeholder for you to fit in your own business logic, for example, for the bank system. But let's see how we can easily adapt them into your own application. The idea is easy. So the idea is basically we are trying to, first of all, rename systematically by using the support tool in Eiffel Studio. We want to rename, for example, from ETF model into, let's say, bank. And also we want to rename ETF model access into bank access. So the contents for these two classes actually do not change, but only the names and also all their references in these classes over here and also in ETF command and in all the other generated classes, those references will be replaced accordingly systematically. That'll be the first step. And then once we rename our ETF model and ETF model access to our own application domain, what we can do later is to gradually introduce the relevant features into our bank class. Okay, and the bank access class will not change because it simply already implemented the singleton pattern, so we don't have to change it. So only renaming will be sufficient for the bank access. We only have to do the bank. And more importantly, for your model cluster, you don't necessarily have to contain only just one model class. So it really depends on what kind of information you need for classes you need for your application. For example, you might later on decide that not only we're gonna have the bank class over here, let me use a different color here. Not only that you want to have a bank class, but also the bank might also have a supplier, which is maybe account class. So you can have as many classes as you like. It's just that you need some entry points for all the command classes to have the client supplier with. Okay, but once you get the entry class renamed from the ETF model, from there you can have as many client supplier or inheritance relations as necessary for your own application. Okay, hopefully that makes sense. So let's do it. As a first step, we're going to rename to the bank and also bank access, and then we'll introduce the account class a little bit later. Okay, let's do it. And let's just review very quickly what we got from before. Okay, before I run the, let's do renaming first, and then we'll review how we run the acceptance tests from the customer's point of view. Let's go to Eiffel Studio, and that's our starter projects. And you don't want to do renaming just manually. You want to do it systematically using the support tool in Eiffel Studio. So right-click on, under the model cluster over here, and then go to ETF model class, right-click, and then go under refactor, and then you say rename. And over here, rather than ETF model, so now for the current tutorial, we are dealing with the bank system. So let's say the entry points for our model classes will be just the bank class. Let's say bank. And then make sure you choose all classes and check the box for all of them. Okay, rename file, replace name in comments, rename in strings, and reuse existing name. Okay. Okay, so now let's say okay. Okay, it's going to do all the renaming for you from ETF model into bank. For example, now if you go to ETF commands, ETF, which is the top class over here, ETF command. If you look at that, if you go to what we used to declare as ETF model, it has been refactored into bank. Okay, but the contents for the bank is just the same as the ETF model as before, but we're going to change the content a little bit later. Let's just make sure all the namings are consistent and correct. Okay, the second renaming to do, let's rename ETF model access into, for example, bank access, or whatever name you like to call that. Okay, let's again right click on ETF model access and go to refactor and go to rename. And again, make sure you choose all classes and check all the boxes over here. And then let's call that maybe bank access. And then we'll say OK. Okay, it's going to rename systematically for you. Okay, so now they do have some warning over here, but if you double click on that, it's actually okay. Remember, in the bank class, we actually said in order to implement the singleton pattern, you will simply say the constructor is restricted only for the bank access class. So this is okay. So don't worry about the warning. You can just click on compile again, and warning goes away. Okay, so now we have done the renaming from ETF model into bank, and also from ETF model access to bank access. So this is what we have. And now for the bank class over here, we can now start to introduce changes that's specific to implementing the model logic for the bank system. We can add inheritance, we can add client supplier, and we can change any features in this class as we like. Okay, so now let's do one thing at a time. And for the remaining part, I might just leave to you as an exercise. Okay, so now let's go to something that we have known from the previous tutorial video. First of all, let's go to the command line. And so now currently the switch has been switched to the command line mode. Okay, so now my current directory is under the ETF folder. So the contents will be just the bank cluster, just bank project folder. Let me go into bank. And remember, we store our acceptance test under the tests cluster. So I'll go to cd tests, acceptance test, acceptance, and instructor. And AT01 was the only one we had. Let's have a quick look how it looks like. Open at01.txt. So basically, we're going to do a new, and then a new, and also deposit, right? New and deposit. And the output we had, let's review very quickly. And ifgens, and then bank, w code, and then bank. Let's say we run the batch mode, and then at01.txt. Okay, that's what we had. Okay, so these are the results from the changes we made in the previous tutorial video, which is different from the default. But we want to make this even closer to our intended bank application. So now we want to, let's say we want to handle, let's say the first two commands a little bit more properly. We want to say, whenever you say new ID1, new ID2, you want to somehow to say, you just want to add it, we want to collect in the bank class a list of account IDs, okay? So that we can just declare, for example, an array or a linked list of ID names. So that'll be a first step. So and then for the states over here, rather than displaying just 1, 2, 1, 3, 5, 7 integer counters, we want to display something that's more meaningful for the bank system. For example, we can display the list of accounts created so far. Okay, I'll show you how you can do it. Okay, let's do this quickly. And then we also try to give you some idea how you can do deposit, and then I'll leave the rest to you. Okay, let's now go to the model cluster over here. Let's go to bank. So what I would do is, let's gradually change that, okay? So now, what I would do is, now, under model attribute, eventually, you want to delete all the model attributes that were generated as part of the startup project eventually, okay? But if you delete them now, things will not compile. So let's just leave them for now. You can eventually delete them. So I would say feature, I would say implementation for the bank. So what I would do is, I would declare IDs, or you can simply say accounts. Currently, we don't have any account class, but we will create that a little bit later. But for the purpose for now, we'll say accounts, which is going to be a linked list of string IDs. And then, whenever now, because we know that from the previous tutorial, we actually knew that over here for this, whenever the user actually initiates a command new, for example, ID1 as a string, we know that it's going to actually call the ETF new class over here. And for the ETF new class, let's remind ourselves of what it's going to do. ETF new over here, you can see the new is going to call model.new. Okay, model is of type bank already. And the new is the feature that we introduced in the previous video, which is currently just assign the string to be new and then increment the counter by 2. We can do something more meaningful here, but let's fix the some errors first. Okay, so we already declared this array, this linked list of account IDs over here. Okay, let's compile, and then you can see that this is the typical void safety message that we will get, right? Because we declare this account's attributes of reference type, but we want to make sure we initialize these attributes in every constructor in the class. But currently we haven't, so that's why we're gonna fix it. And make is declared as a constructor, so that's why we're gonna initialize the accounts over there. So what we'll do is, well, let's say over here, but eventually we'll get rid of these two lines because they are to do with the default model attributes. So what we can do is we can say create accounts.make. So this will create empty accounts IDs to begin with. Okay, let's say compile, and then this will simply just work. Okay, and then we want to make sure every time the new feature is called in the ETF new over here, every time the user wants to initiate an event for adding a new ID into the bank system, we make sure when the model.new is called, we're going to actually do something about it. We can just add an ID into the accounts. So we can say accounts.extend. Okay, and then the new over here, let's add more parameter here because new here should really take some ID. So what I can do is I can say ID string over here, and then we can say extend ID. As soon as we say compile, it wouldn't compile because over here you can see that over here in the case, let's say in the class of ETF new over there, we simply just call new. However, here we are calling a feature that is expecting an ID, right? So that means we got some inconsistencies here. So the way to fix it would be go to ETF new, and then we want to say new here, and then you simply pass the ID that we got supplied by the user. Okay, and then with a compile over here, okay, everything compile. Let's go back to the bank. So now every time when the user initiates the command for new ID1, for example, and then somehow when we go to the class for ETF new, the command class is going to call model over here dot new, which we already just created, and the model.new is going to extend the accounts for the model bank by 1 ID. Okay, that's what's going to happen. And not only that, what we want to make sure is the states of the bank can actually reflect this. So let's rewrite this part over here. So whatever we rewrite as a new version, it will be displayed accordingly in the output states when we run the acceptance test. So now what we can do is, let me just comment these out over here. Let's just do something completely different. So I can say result is of type string. So I can say create, let's say result.make empty string to begin with. And then because account is simply a linked list, let's use the across syntax. Across accounts as, let's say account cursor, or you can just call it cursor, how about that? And then we're going to simply just write out the ID for the account. So now let's make it a little bit pretty printing here. Result.append. Let's say we use the set notation. So we got start with some curly brackets over here, and then we can end it with some curly brackets here. And then we also want it to be comma separated, so we can also introduce a loop counter over here explicitly. I integer. Okay, what I can do is I can say initialize I to be 1. Okay, and what I can do is, and at the end of each iteration, I can simply increment I by 1. I is assigned to I plus 1. And then I can say if I is not the last item I'm looking at is actually less than accounts.count. That means I need to append a comma. Result.append a comma followed by space. Okay, and then before that, I should also print out the ID for the accounts, the current one I'm looking at. So result.append, and then I can say cursor.item. Okay, so let's see if that will work. Of course, Let's see over here, local identity. Oh, it's because remember we actually got a model attributes called I, so we just cannot call it I. Okay, what about I just call it J? Okay, just as a workaround. Okay, and then I can rename that to J, and then rename that to J, and rename that to J as well over here. Okay, let's see if that will compile. Of course, sometimes when you write a piece of code, you just want to test. That's why you got to run the batch mode again. Okay, that's why batch mode is so useful than much more useful when you run the regression testing. And now we are really doing regression testing because we are simply changing the model part and we want to know how the external behavior of the whole application is going to be modified accordingly. And you just don't want to retype manually all the test cases using the interactive mode or the GUI mode. Batch mode in this case is your friend. Okay, so now let's compile and make sure it compiles. And then what we will do is we'll go back to our batch mode over here and let's see what happened. Okay, we're just gonna rerun this test case. Okay, you can see that it's pretty good. You can see we start with the state with empty list, empty set of account ID. After new ID1, we actually got ID1 being added over here. And after ID2, we actually got 2 IDs over here. And after deposit, because the ID doesn't really change, so we got ID over here. ID1 and ID2 remain the same. Okay, hopefully this is the idea. So I would say that new more or less actually works. But now the problem is, remember the original test over here, we also need to do some deposit. We want to deposit into the account with ID1, $234. But the problem is currently you can see the type of the accounts attributes that we just created. Okay, you can see that accounts over here, we simply got a linked list of string. String is simply just a string value for the ID. It's not really an account object. So that means we may want to introduce more classes for our model. Okay, that's exactly what I said. Given that, it's really important to emphasize this again. You can see over here, after renaming ETF model into this bank class over here, this is just the entry points for your entire model collection of model classes. Now from there, you can just create any inheritance or client-supply relations as necessary. In this case, we found that for the bank, we might need just another supplier called accounts. Okay, so let's see how we can do that. Okay, very easy. So what I will do is, I will first of all, under the model cluster, I will introduce a new class. So I'll say new class, account, over here. Okay, and then to make sure we do have the client-supply relations, let's go back to bank. So now rather than string, I'm going to put account. Okay, of course things may not just compile because over here you can see now when we say cursor the item will now be account type, right? Because account is now a linked list of accounts. So cursor is no longer a cursor to string value. It's going to be a cursor to account objects. So you cannot directly append account objects to the string value. Okay, but what we can do just for now, because like in Java, every object has the toString method defined. Also in Eiffel, every object has the out feature defined. I can just say out for now. But we're going to redefine that out in just a moment. Okay, and also accounts that extend rather than ID. So what we're going to do is we're going to create an account object accordingly. Okay, I'll do this in just a moment. So now let's just go to our account objects over here, account class that we just created. Let's define that very quickly. Okay, I can say create, make, and before that I can say also inherits the any class, and I'm going to redefine the out feature to print out what the account is. And also we can say make over here, and then what we can do is first of all feature class. So now let's first of all define the commands. And make is one of the commands that will be chosen as a constructor. I would say do. Okay, and then let's also define maybe the attributes for the account. So I can say feature attributes, and then let's say each account has an ID, also has a balance. ID is a string value, and also balance is maybe some integer. Okay, and then I'm going to say for the make, we're always going to pass maybe the ID. So when the user actually say new and then ID 1, so we can create the account objects accordingly. Okay, and then we can simply say, so here, I will say new ID, and then ID is assigned to new ID. And the balance by default will just be maybe, let's say 0. Okay, and then it's complaining that we said we're going to redefine out, but we haven't done that yet. So let's do it. So now I can say feature, I would say output. And over here, I'm going to put the out feature. So I can say out, return a string. And then I can say result is assigned to account with ID, and then I can put ID over here. Oh, actually ID here has balance, and then I can say balance, which is integer, the string value. Okay, let's compile and make sure it is okay. Okay, so now let's go back to this new feature in the bank. So now what we can do is we can once the user pass an ID to call the new feature in the model by passing an ID value. What we can do is now rather than just passing the string value, we can create the account objects. We can say create account.make and then ID over here. Okay, let's compile. Okay, everything compile, and of course, it's always a good practice to think about what does it really mean to have integrity for your classes. So we can say class invariance for the bank for the account would be, let's say balance is always larger than 0. Okay, that's what we can do. Maybe larger than or equal to 0. Because otherwise, if you say larger than 0, then initially the default value for balance would be 0, which does not satisfy the invariance. So let's just say it's larger than or equal to 0. It could be 0 to start with. Okay, and now what we can do is we can also define at the account level maybe some deposit. Since we want to do deposit, remember in the acceptance test we want to do deposit. Let's say deposit, let's say we have some amounts over here in the account class, let's say integer. Okay, and then we're going to say balance is assigned to balance plus the amount. Okay, that's at the account level. But now in the bank level, the deposit will be a little bit different, right? We're actually going to get the ID denoting the account we'd like to deposit into. So what we're going to do is ID of type string. So we're going to find out that account first, and then we can say also ID string and also amount integer. Okay, and then over here, so these ones I will simply comment them out. Okay, we delete them eventually. What I can do is, first of all, I need to find out where that account is. Okay, what I can do is I can say across over here, across the accounts over here as cursor, I can say if the current account I'm looking at has the ID that is equal to, so I can use a tilde notation that is equal to the ID, then I'm going to do the deposit. Okay, and then I would say cursor.item.deposit, and then I can deposit the amount inside. Okay, so you can see the deposit actually exists. So I will deal with this compile time error in just a moment. So deposit exists in two levels, both at the bank level where we require the ID information, whereas in the account level, we only need the amount, since we already know what the account object it is as a current. Okay, so now the compile time error we got is, now from the user command level over here, which is ETF Deposit, okay, used to call only the deposit over here without actually giving any information. But let's now change that since we already modified the model side. Okay, let's do that. And let's say model.deposit. So we should pass the ID and also the amount. Okay, let's see what happened. Okay, so now we still have some compilation error. Let's see exactly what happened. Okay, let's expand the error messages and see what happened. So now basically it is complaining the following. So when we call the deposit in the ETF deposit over here, okay, so now it is saying that the formal argument simply means the parameter type for this particular deposit feature, right? So let's think about what the parameter type is. What's the type for the second parameter for this deposit feature in the bank class? Okay, let's have a look. If you go back to the bank over here, the second parameter is integer. Implicitly, when we say integer in Eiffel, it's integer with 32 bits. Okay, integer with 32 bits. However, if you see the next one, actual argument over here is when we call that feature, the value we actually pass is integer 64. Okay, let's verify that. If you go to ETF deposit over here, you can see that we are passing amount, which is the actual arguments. But what's the amount? Amount was declared as integer 64. So basically, we are trying to store a 64-bit integer into a much smaller box for the integer 32 bits. So that's why it's inconsistent. Okay. So that's simply because for ETF framework, we by default, whenever you talk about integer in the let me just show you here. Remember, this is the abstract user interface file that we got. Okay, by default, whenever you mention about integer in the user interface file, it's actually by default it's going to be 64 bits. It's as if you put integer 64 in the Eiffel site. But now we are passing 64 bits integer into a feature that is expecting to take 32 bits integer. Okay, so now how can we resolve this? Very easy. Okay. If you got similar problem for your project, this is how you can do it. So it's actually quite normal. We just have some inconsistent data types between the user interface side and also the model side. So at the user interface, at the user command level over here, you can resolve such inconsistency. That's completely normal. Okay. What we will do is we can simply declare a local variable over here. Let's call that. So that's simply the amount. I would say A over here, okay, and this should be integer. In the Eiffel side, integer means integer 32, okay. So now what I can do is I can say A is assigned to amount. If I only try to compile this, it's not going to compile, right? Because amount is 64 bits and A is 32 bits. I can say amount dot to integer 32. Okay, we can simply convert that. We want to do some to cast that into 32 bits. Okay, and then rather than saying amount, we're going to pass A, and things will compile. Basically, we do the type conversion at a user interface level rather than the model level. The model might be ported to other user interface later, but for the user interface, we can resolve any inconsistency between the user interface and also the model. Okay, so that's done over here. So now what I would like to do is to go back to the bank class over here and modify the out feature a little bit more. Okay, so now what I can do is, so now we used to print out, actually, you know what, it will be done already in the bank side, because over here we simply say cursor the item which is of type account. The out, but have we redefined the out? Yes, we have. So you can see the account over here is simply going to call this version, the redefined version for the account. So now let's make sure it compiles, and then if we try to rerun our acceptance test, let's see what's going to happen. Okay, so you can see that account with ID 1 has balance 0. That's after we added the new ID 1. And then after adding new ID 2, we actually got two accounts. We got account with ID 1 has balance 0, account with ID 2 has balance 0. But now after deposit into ID 1, we actually got that modified to be $234. And for the ID 2, it's still $0. Okay? Hopefully you see how it works. Okay? You can make it as fancy as you like. So now just one more change to introduce for you. So if I go back to the bank class, so now I can try to give a name for the sets. I can say accounts over here, compile, and then I'm just going back over here, and then rerun the test. I can just say accounts over here. So that means the curly brackets tell you there's a set of accounts, and then it's going to say account with ID1 has balance, depending on what the current accounts are. Okay, good. Okay, hopefully you see the pattern over here from this tutorial video. So we have just done changes in the model side by first renaming the classes, and then we can also add more model classes. So again, here's the principle. After renaming from ETF model into bank, you only have one single model class. But as you develop your project, you might find that you may want to add more descendant classes, more ancestor classes, more supplier classes, or more client classes. So these are completely up to your need for your application. Okay, that we just illustrated that how you add an account class as the supplier. Okay, so after this, we rerun our test cases over here, and things seem to be working towards the right direction. Okay, what I would like to assign to you as an exercise is, can you please complete the following? Remember back in over here, we just completed a new and deposit. I would like you to try to complete a withdraw and also transfer. Okay, basically you have to modify the features for withdraw and transfer in the bank class and in the account class accordingly, and also you want to make sure you also modify how you call them in the ETF withdraw and also ETF transfer. Okay, so these are the changes you have to make. I'll leave them to you as an exercise.